Hello everybody, it's Mrs. Pound, and I'm back with the last video for Chapter 6 on the periodic table and elements from BJU Chemistry's 5th edition. So today we're going to focus on Section 6.3, Elements by their Groups. So our objectives today will be to name the groups and series that are included in the periodic table, describe the general physical and chemical properties of each group or series, and predict physical and chemical properties of elements on the basis of their locations in the periodic table. So first we're going to start with the hydrogen family, which consists only of hydrogen. That's why it kind of floats up here on the periodic table, because it doesn't really fit in with the rest of its group. It is the lightest and most abundant element in the universe. In fact, it's what makes up mostly our sun. It's extremely flammable in air. This is the Hindenburg that exploded. It exploded because it was full of hydrogen gas, because it is so light, it floats, but extremely flammable. And it's used in the industrial production of ammonia. So group 1, the alkali metals, that's this group here, excluding hydrogen, because hydrogen is a gas. The rest of them are solids and metals. They have a silvery luster. This is sodium here. It conducts heat and electricity well. They are highly reactive, though. They're not found in nature as the metals on their own. They have a low density compared to other metals, and they have one valence electron. Remember, we determined the valence electrons by the group number. Group 1 has one valence electron, and they tend to like to give up that electron to form a positive 1 charge, a cation with a positive charge. Group 2, the alkaline earth metals, right here, group 2. They're mostly geologic metals that are dissolved slightly in water. They are solids at room temperature. They like to form alloys, which alloys are mixtures of metals. And they have 2 valence electrons, which means that they like to lose those electrons and form a positive 2 charge, as we see here on the periodic table for the oxidation states. Groups 3 through 12 are called the transition metals, right here in the middle of the table. This is a large group of elements that have their highest energy electrons in interior d sublevels, so we also call this the D block. They generally have high melting points. There are some exceptions, though, because there's mercury, which is a liquid at room temperature. They generally are dense and hard. And they have 1 or 2 valence electrons, because that's what they have in their S sublevel. They can form cations with various charges. And so we see that with their oxidation states. You can see that there are a number of different oxidation states for most of them. Then there are the inner transition metals. These are the metals down here in the F block. They are called the lanthanoid series, the actinoid series, and they are part of the F block. The lanthanoid series are on the top, the actinoids are on the bottom, and they're simply named for the first element in the series. And so the lanthanoids and the actinoids right here is why they're named that. Group 13 is the boron group. So right here, remember 3 valence electrons, because for groups 13 through 18 we drop off the 1. So 3 valence electrons. This is aluminum. Aluminum is highly conductive, has a low density, and corrodes in the presence of atmospheric oxygen. It's probably the most important and element that you would most recognize from this group. Group 14 is the carbon group, right here, because carbon is at the top. They are solids at room temperature, and this is diamond in the background. They have low reactivity, and they can take many forms. For example, carbon Can be graphite, which we use in pencil lead, or diamond. So it can be very soft, so soft that it rubs off and we can write with it, or it can be a very hard substance. And it has 4 valence electrons. Now, carbon tends to like to form, instead of forming cations or anions, it likes to form covalent bonds instead of ionic bonds. Group 15, the pnictogens, with nitrogen at the top, right here. The elements in this group are nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. This is a very varied group because we see a gas at the top and we see solids with varying properties really as we go down, because we have gases, nonmetals, we have metalloids, and we also have metals in this group. So a very varied group. Also, you'll notice here it has 5 valence electrons. And again, this tends to like to form covalent bonds, these do. Group 16, the chalcogens, with oxygen at the top. Oxygen is probably the most important element in this group, and it is a diatomic or triatomic gas that accounts for 21% of the Earth's atmosphere and is the most abundant element in the Earth's crust and is essential for life. So that's why I have this picture in the background, because it being essential for life. Oxygen also has the ability to combine with other metals to form compounds called oxides. We see here in the background something made of iron, and it is rusted. That is iron oxide on this. It can also corrode things like copper and form copper oxides. So right here, tends to gain 2 electrons for a positive 2 charge for an anion, or negative 2 charge, excuse me, for an anion. Group 17 are the halogens. So right here, they are fluorine, chlorine, bromine, iodine, and astatine. Halogen means salt producing. So they produce salts. They tend not to be found by themselves in nature either, because they are very reactive. So they're highly reactive. Fluorine is actually the most reactive element on the periodic table and the most electronegative. And it contains 7 valence electrons. So because they contain 7 valence electrons, they tend to want to take on one more electron. So the negative 1 charge here, so they're going to become anions and form ionic bonds, especially with our alkali metals and our alkaline earth metals over here. In group 18 are the noble gases, the last group on our chart. These are helium, neon, argon, krypton, xenon, and radon. They avoid combining with other elements, but can be forced to form compounds with other elements. So they don't like to, but they can be forced to. And they have 8 valence electrons. That's why they're pretty happy, because they have an octet. Now, recovery of the rare earth metals. These are metals that are not very common on Earth, but we might want to recover them because they can be useful to our world, perhaps in industry, healthcare, or education. But the cons are retrieving them may potentially expose people and the environment to hazardous levels of chemical compounds and even radiation. So recovering these things, getting them out of the earth is difficult because they are rare. And then it's important that if we want to recover them, that we get them out of materials that are already mined, and that we not send them, say, to a landfill, but they are recovered, that they are recycled. So our objectives today were to name the groups and series that are included in the periodic table, describe the general physical and chemical properties of each group or series, and predict physical and chemical properties of elements on the basis of their location in the periodic table. So don't forget your 5 questions in your notes, and you can start studying for that test because we have covered everything in this chapter.